For our final lesson here, I would like for us to look at how to access some of the elevation data that the Wolfram language can get to, because I know that elevation data and digital elevation models are often something we work with in GIS. Plus, I want to show you how easy it is to start getting three-dimensional renderings of your data using the Wolfram language in this notebook environment. So you do have access to elevation data from around the planet, and we have this function called Geo Elevation Data right here that, as you can imagine, takes the input of different locations. And of course that can be latitude and longitude, or it can be some type of location that it understands. So for instance, if I wanted to get my elevation, I can get it from my current location. So I'm currently 531.469 feet above sea level as far as it understands the data and as far as it understands my exact location. And of course, instead of calculating for my position, I could calculate for a positional entity that it understands, or give it some coordinates and have it pull that position. But often we're interested in the elevation across a region, and we can get to that data as well. There are a number of different data structures that the Wolfram language recognizes, and one of these is an array. So rather than having just one number for an elevation, we could have a bunch of numbers which indicates the elevations across a region. So, for instance, we could ask for Geo Elevation Data, but this time let's create a geodisk, and let's do it around Mount Everest, and let's say that we want 10 miles around Mount Everest. So here's what it returns as the result of that computation. It's got quantity array, and then it's got this little bit of information here. So it did return information that had to do with all of the elevation surrounding Mount Everest, but I haven't told it to visualize it in any way. I just got the return of this quantity array that tells you some information about it, like it is in feet, and then it gives you a maximum and minimum elevation or value, which in this case does happen to be elevation since this array was created from an elevation data set. But I haven't asked it to display that data, and I'd much rather have some type of visualization of it. So one of the things that we can generate is called a relief plot. So let's do a relief plot now, and there it is. And if I click down here, you can see that what the relief plot is expecting to have as input is an array. And fortunately, that's exactly what I just generated up here, an array. So I'm going to open my brackets, and as it just so happens, there's a shortcut to tell the Wolfram language to run this function, or to use the result of the previous calculation. And so I'm going to use that, which is the percentage sign. So when I say relief plot with the percentage sign in the brackets, I'm saying run the relief plot on the result of the previous calculation. Let's see what we get. There we go. That's the data that was stored in that array shown as a relief plot at the resolution that we've got. And also, of course, as you might expect, we can manipulate the colors or anything like that if we wanted to. But now, of course, we could do any type of calculation that we wanted on that array and display it however we like, because there are lots of things that we can do in GIS and that we like to do on relief data sets. I'll tell you what let's do. Let's go back and readjust this right here, and I can do that just to get some more data to work with. Let's go 100 miles. And then tell it to rerun this calculation. Okay, so I have a new quantity array of new information, but notice that it didn't update this relief plot. I said use this relief plot based on that information, but it doesn't live update like in a chain all the way down through your cells. But I want it to recalculate this, so I will specifically tell it to reevaluate this cell. Ah, there we go. That's a much more interesting kind of display here. Let's try another way to display this data. And you may have been wondering, well, do I have to use this notation here, this percentage sign notation? Could I have just wrapped relief plot around this? And yes, I could. I just want to show you these different ways of doing things. Let's make a contour plot of this. I'm going to use the function list contour plot, and what I'm going to do is just feed it directly this information. List contour plot. I need my brackets. And for this computation, I'm going to back this down just for the sake of the amount of data we're working with, back down to 10 miles. And there, now we have a contour plot of the area around Mount Everest. And of course, we can adjust all of the variables about how this is displayed as far as contour interval and all of that if we wanted to. As a final example, though, let's do a three-dimensional display here. So we're going to use list plot 3D right here. And we can click down and see that it is expecting an array. And we know that we can get an array by running this calculation right here. So I'll just feed it right back into this. And there we go. We actually have a three-dimensional model of the elevation around Mount Everest that we can manipulate and rotate and look around. And once again, we could manipulate all of those axes and anything else we wanted to do. But that's a quick way to get a three-dimensional visualization, an interactive three-dimensional visualization of any type of array of three-dimensional data. And if you wanted to, of course, you could wrap that in manipulate tags to be able to adjust different variables, and you could also wrap it in a cloud deployment tag and send it out to the web for somebody else to look at and manipulate as well. I think we are just about out of time, so that's going to have to pretty much be our look at the Wolfram language for GIS and geospatial analysis. I'll come back with you for one final video where we wrap things up and talk about where you can go from here.